Okay, so now that we have the mass of 1 penny, we're going to calculate the amount of copper. So we know that there's 32% copper in the penny. So I will take 3.0822 grams and I'll multiply it by the percent of copper in decimal form. This is 5 significant figures. This is 3. So when I do the calculation, I come up with 0.986 grams of copper in 1 penny. Okay, remember that number.
Okay.
Okay. We do the exact same thing. Now we use percentage of zinc. And I get 2.09, again, 3 significant figures, 5 significant figures. This actually rounds to 2.10 grams of zinc in 1 penny. Okay, so now we've got the mass of copper, we've got the mass of zinc. All we have to do is figure out how much that costs. 1 pound of copper costs $3.53. 1 pound of zinc costs 0.974. Well, we don't have a pound of copper, we don't have a pound of zinc, we have that much copper, we have that much zinc. So now what we're going to do is we're going to convert those grams into pounds so that we can use that conversion. So we have 0.986 grams of copper. We'll convert the copper, the grams of copper, into kilograms, and then we convert the kilograms into pounds. There are 2.20 pounds in 1 kilogram. And then the last step is to convert the pounds into dollars, and 1 pound of copper is $3.55 3/10 of a penny. So now let's calculate that out. And that comes out to be 0.00, and we have 3 sig figs, 4 sig figs, 3 sig figs, so we're going to round to 3 sig figs, $0.0771. In other words, 0.771 cents. And now we do the exact same application with the zinc. 2.10 grams of zinc, converted into kilograms, and 1 kilogram is 2.20 pounds. And 1 pound of zinc is $0.974. And we do the math. And I get 0.00450 or 0.450 cents. So the total cost of the copper and the zinc in 1 pre-1982 penny I would get by adding these two numbers together. So 0.771 cents plus 0.450 cents is equal to 1.221 cents, and we will round to the thousandths place because with an addition and subtraction you round to the guess furthest to the left. So the metal in a 1 cent penny costs 1.221 cents according to the data. Okay? Now you do the exact same thing for step numbers 10 and for step number 11. And except you will then use your post-1983 data, and for the mass of pennies, you will use the mass of 25 pennies for your post-1983 pennies, data table 2. Number 12 and 13 ask you to calculate percent error. Now, percent error tells you how far you are away from the real value. Percent error or a little wet still. Percent error is equal to your experimental value minus your theoretical value divided by your theoretical value times 100%. You take the absolute value of that. So the experimental value is what you got in the experiment. The theoretical value is the real value. Now if you go to the Treasury homepage, you will find that for pre-1982 pennies, they were 95%, actually 95.0% copper, and 5% zinc. Okay, those are the real values. Now you are going to calculate your percent error for both copper and zinc. Well, your experimental value is what you got in step number 8. Okay, and in step number 8, I got 32% copper. That's my experimental value. I will subtract the real value and divide it by the real value. Take the absolute value and multiply by 100%. So 32 minus 95 divided by 95 times 100 gives me a percent error with 3 sig figs, 3 sig figs, 3 sig figs of 66.3% error. I would then go on and do the exact same thing for the zinc. The zinc I came out to have 68% from step number 8. I will then subtract the real value, 5%. Divide by the 5%, take the absolute value, multiply by 100%. And I end up with a large error of 1,260% error. Okay? So this is how you calculate percent error in step number 13. In step number 14, you use the exact same formula. Except now you'll be using the percentages you found in step number 10. Those are the percentages from the post-1983. Now the real value, the theoretical values, are in post-1983, there's actually now 2.5% copper, and there is 97.5% zinc. So now you use these theoretical values in step number 14 and you go ahead and calculate the rest. So, I hope you've enjoyed this as much as I have. What do you think? Do you agree with all the information? I guess you do. Well, this has been another edition of Mr. Strauss's Chemistry Corner. Goodbye.